Let's begin our journey at home. Earth, a planet orbiting an ordinary star, the Sun. Our Sun is just one among hundreds of billions in the Milky Way galaxy. Imagine, hundreds of billions of stars, many with their own planets. The Milky Way is a swirling city of stars, but it's only one of about 2 trillion galaxies in the observable universe. Each galaxy holds billions or trillions of stars, a scale that's almost impossible to grasp. When we look at the night sky, we're seeing light that's traveled for millions of years, time capsules from the distant past. The Andromeda Galaxy's light, for example, began its journey when our ancestors first walked the Earth. Every point of light is a message from another place in time. With so many stars and planets, could we really be alone? The numbers suggest otherwise. There are more worlds than grains of sand on Earth. To think life happened only here seems extraordinary. The universe is vast, and it's unlikely the story of life is unique to our tiny corner. Our cosmic address is just one among countless possibilities. The question isn't just where we are, but who or what might be out there with us. The search for life is a search for connection across the universe. What does life need to begin? On Earth, it starts with liquid water, a universal solvent where chemistry comes alive. Water allows molecules to interact, forming the complex structures of life. Next, energy. Sunlight powers most life here, but deep-sea vents show life can thrive on chemical energy too. This means life could exist in darkness, far from any star. The building blocks are crucial: carbon, hydrogen, nitrogen, oxygen, phosphorus, all forged in stars and scattered across the cosmos. Life is literally made of stardust, but raw materials aren't enough. A planet needs stability. It must orbit in the Goldilocks zone, not too hot, not too cold, for liquid water to persist. Too close to its star, water boils away; too far, it freezes. A stable orbit, atmosphere, and magnetic field help protect and nurture life. The universe is full of planets, but only a few win this cosmic lottery. Our search is for those rare worlds where all the ingredients come together. Finding them means finding the places where life could take root. The recipe is simple, but the outcome is extraordinary. How do we search for life on distant worlds? We use telescopes and the language of light. The transit method lets us spot exoplanets by watching for tiny dips in a star's brightness as a planet passes in front. Kepler and TESS have found thousands of exoplanets this way. Next, we study their atmospheres, analyzing starlight that filters through to look for biosignatures like oxygen, methane, or water vapor. On Earth, oxygen and methane together signal life. Finding similar signs elsewhere would be a major breakthrough. For intelligent life, SETI listens for radio signals, patterns, or messages that stand out from cosmic noise. So far, we've heard only silence, but the search continues. Detecting life in other galaxies is even harder. Their light is faint, and signals are weak. Our technology limits us mostly to the Milky Way for now, but as our tools improve, we may one day search for life in Andromeda and beyond. Each discovery brings us closer to answering the ultimate question: are we alone? The universe may be whispering, we just have to learn how to listen. To estimate intelligent life, we turn to the Drake equation, a formula multiplying factors like star formation, habitable planets, and the odds of life and intelligence. Most of these numbers are unknown, so the answer could be millions of civilizations, or just one. This leads to the Fermi paradox. If life is common, where is everyone? The galaxy is old and vast. If civilizations were out there, shouldn't we see evidence, signals, probes, or megastructures? Yet the universe seems silent. Maybe we're alone, or maybe civilizations are rare, short-lived, or hiding. Perhaps we're not listening the right way. The paradox forces us to question our assumptions and our place in the cosmos. Are we the first, the only, or just one among many? The silence is as mysterious as any signal. If we find life in another galaxy, what might it be like? Life adapts to its world. On high-gravity planets, creatures might be squat and sturdy. In low-gravity, tall and delicate. Some life could float in gas giants' atmospheres or use silicon instead of carbon. On frigid worlds, life might swim in methane seas, breathing hydrogen. Alien plants could be black to absorb faint starlight or iridescent to reflect harsh rays. Senses might be unimaginable, seeing with magnetism, hearing through vibrations. Intelligence could be a hive mind or a planet-wide network. Their art and math might be beyond our understanding. The search for life is a search for new possibilities. Whether we find it or not, the act of searching connects us to the cosmos. Wondering what's out there is what makes us explorers at heart.